Okay, so here's a slightly neater version of the diagram that I just drew for you on the whiteboard. We've got the Earth's surface and solar energy coming in from above, energy from the Earth's interior coming up from below through the lithosphere, the solar energy coming in through the atmosphere, solar energy affecting the atmosphere, Earth's interior energy affecting the lithosphere, all of that affecting the surface. And I've here broken down the surface into four different conceptual regions, if you like. The hydrosphere, those parts of the Earth's surface system that involve or include or are composed of water. Cryosphere, the frozen portions of the Earth system, glaciers, ice in the atmosphere, and so on. The biosphere, the living parts of the system, and the pedosphere, which is the soil-related part of the system. And what I asked you to do in the whiteboard exercise was to add your own examples, illustrations, case studies onto a diagram of this type, so that you can see for yourself where everything fits, where the glaciers fit, where the volcanoes fit. So let's have a look and see what you might have begun to do for that. Just taking some notes first of all before you start drawing your lovely diagram. Here's a version with a few notes thrown in as to where I might begin to put some of the big issues that I associate with physical geography. So soils obviously clearly belong with the pedosphere, glaciers in the cryosphere and so on. Climate and weather and the hydrological cycle are kind of sketched up here somewhere in the atmosphere. Try and think of all the different components of physical geography as you've defined it, or as you conceive of it, and try and add them somewhere to this diagram. Where's the radiation balance going to go? Where's plate tectonics going to go? Where are lahars going to go? Where's permafrost going to belong? Just try fitting everything together. If you can fit everything together, then so far so good. If you can't, then it might be that you just need to think a little bit longer about it, or it might be that the system that I've drawn for you doesn't work. There might be something wrong with this that means that not everything quite fits correctly. And so we can keep working on this system. Like I said before with the textbooks, you don't have to stick with what it says in a textbook. You don't have to stick with a model that I give you to play with. You can develop it, you can improve it. So keep working on this and make your own versions of this diagram and make better ones with actual diagrams of the processes and the features included on it as well. But just try fitting everything together to show what are the components of physical geography in terms of this core subject matter, which is part of the definition of physical geography. It's not the whole definition, remember, it's subject matter and approach or method, but this is a core part of the subject matter that we're looking at now. And an important thing to remember about the subject matter of geography, or of physical geography, is that it overlaps with other disciplines. Geographers look at volcanoes, well, geologists look at volcanoes. Geographers look at soils and biogeography. Well, that overlaps with soil sciences, life sciences. There are lots of overlaps across the discipline, and particularly at the edges of the discipline where we meet other subjects. That isn't in any way a problem for geography or for the other subjects. It's a strength, because often it's our interactions with other subjects where the most valuable progress and most valuable contributions to society or to human progress or to human understanding of the natural environment, one of the big things that we're after, those improvements often happen right at the boundaries of the subject where we're interacting with other disciplines. So that's a word about the subject matter of physical geography. You can read up around all of that, obviously. But I want to say a word also about the approach or the method of physical geography. What is our method? What is our approach? Well, first of all, fundamentally, carrying on from what we said in the previous section, we adopt a geographical approach. This is physical geography, and the geographical approach is the use of spatial evidence or geographical evidence, and using clues that are embodied within geographical evidence to answer our questions. That's the geographical method. For physical geography, we also adopt a scientific method. And I asked you earlier on in this step what you thought the word science meant. What is science, and what is a scientific method? So let's have a little bit of a think about that. And the first thing to remind ourselves of is that science is more than just test tubes and Bunsen burners and people in white coats in a lab. That's an example of one type of science, but that isn't the definition of what science is. And I put a few notes on this page for you to have a look through. You can silence me and pause the video and have a read through those notes and see what you think of them. But these kind of lead us towards a more useful way of thinking about what science is when we say that physical geography is a science. What do we mean by that? Well, science is a way of understanding the world. It's a particular approach to understanding the world and organizing our view of reality to make reality make more sense for us. The world is a complicated place. You can look at it in lots of different ways. You can understand it in lots of different ways. Science is one of those ways. There are other ways as well, and this isn't the place to argue about science or religion or art having precedence as a way of looking at the world. But for this module, and for the most part, physical geographers around the world take a scientific approach to the discipline. So that's what we're going to focus on. And science is all about understanding things better and specifically finding things out. There are things that we don't know. We want to know them. So how are we going to go about finding those out? And science is a way of doing that. In particular, science is a way of getting reliable answers, answers that we can have a fixed degree of confidence in. We know if we're 50% certain or 75% certain or 98% certain, we have a degree of confidence in how reliable and how repeatable our answers would be if we did the same experiment again, or if we made the same observations again next week, or if a different person went out and did the same observations that I had done. Would they see the same thing, or is it a subjective matter where different people's opinions make a big difference to what we're seeing? Those are the kinds of questions that scientists worry about. And they do that in the context of what we call the scientific method. And at the heart of the scientific method are these things. Observations. We measure, we count, we look at the world around us and we observe things. We collect data, we collect information from those observations. That might be through field work, going out into the world and looking around and counting pebbles, measuring the density of soils, all these kind of field work activities that you might already have had some experience with. Or it might involve lab work, being in the laboratory, conducting experiments with materials to find out how they work. So we've got observation, we've got data collection. And then we add to that logical reasoning. For example, the idea of hypothesis testing, which is coming up with an idea and then checking whether it can logically be valid or not, given the evidence that we've collected from fieldwork or lab work. That's an example of logical reasoning that leads us to a conclusion. We'll say a lot more about that in later sections of this degree program that most of you watching this will be doing. But for now, just take that as a kind of definition or a key note towards understanding what the scientific method is about. It's logical reasoning using observations or collected data to get answers to questions. So science, if you like, down at the bottom of the list there, science is the application of evidence and logic to clearly define questions. Not all questions are amenable to scientific research, and that's where science, religion and other ways of looking at the world sometimes don't overlap or can't overlap, because there are questions that science can't address. There are other questions that science is particularly well suited to addressing, and physical geography is full of questions that are absolutely suitable for science to approach, and that's the way that we're going to approach them throughout this program. Now, talking about science in physical geography could lead us, and does lead us conveniently, into a point where we could talk at length about the history of the discipline. It is important that you know a bit about the history of the discipline in order to put how physical geography works today into an appropriate context, but I'm not actually going to talk about that in these sessions. I'm going to leave you to read about that as part of your independent work, your guided reading, as we call it, associated with the sessions. So I've put a couple of key readings up there for you to go and have a look at, and from those you will find something about the basic history of the discipline, just so you can see where we've been, where we've come from. Are we a young discipline? Or an old discipline? You need to just have a little bit of that context under your belt before we move on to the later sections of the course. So I'll leave that reading up there for you to go and have a look at. It's all available in the library. Check the reading lists that you've had made available to you. we will encounter an awful lot of other characters later on during the course of the module. So before you move on to the next part of this step, I'd just like you to go back to your definition of physical geography that you made at the beginning of the session and just revise that. We ask you to write down a definition that included both the subject matter and the approach. We've talked a little bit about each of those. You can now extend those definitions that you wrote down earlier and try to make something a little bit more comprehensive. And if you're having tutorials as part of your degree program, then this is a really good topic to take to a tutorial and share ideas about what makes physical geography what it is. All of the things that we've touched on today we'll come back and look at in more detail as we move further through these steps and further through this module.